Hey, happy Monday, kids. Make sure you watch my other video after this, just to give you a brief rundown of the week. The other video is about 4 minutes. This one is about 20. So make sure you watch the other one either before this or after it, either one. So I hope you guys had an okay spring break. I know we're stuck at home, but today we're going to be learning about the planets in our solar system. We're going to talk about each of the 8 planets, some cool facts about them, some cool information about them, and then we'll talk about dwarf planets a little bit as well. So our learning target for today, I can describe the orbit and key features of the 8 planets. So the 8 planets, first we'll get to the orbits and the key features in a few minutes, but the 8 planets in the solar system, I hope by now you're a little familiar with those. We have 4 rocky planets. That would be Mercury, Venus, Earth, and Mars. And then an asteroid belt. And then after that, we have our gas giants, which are Jupiter, Saturn, Uranus, and Neptune. And then we have some dwarf planets, Pluto, as well. And those are the ones we're going to be talking about. So the week before spring break, I had you guys make a storyboard poster of facts about individual planets. And one of the questions that a lot of people had were, you're asking me for the length of a year and a day, but I don't know what that means. So I just want to take a few minutes and explain what I mean when I say how long is the year and how long is the day. So let's start with, what is a year? A year on each planet is different. The amount of time it takes is different. But the definition of a year is how long it takes the planet to travel in its orbit around the sun. We say it revolves around the sun. So we have Earth here. It takes 364.25 days for the Earth to make it from one end of its orbit all the way around and back to that spot. Each planet, depending usually on their distance from the sun, will take a different amount of time. When we talk about the year, I'm talking about in terms of Earth days. So that if I say, oh, a year on Mercury is 88 days, that means it takes 88 Earth days for Mercury to go all the way around the sun. So a year varies on each planet. It's a different amount of time, depending on how long it takes to complete its complete orbit around the sun. A day is different. As a planet travels around the sun, it's also spinning or rotating on its axis. So Earth rotates. It takes 24 hours for it to go in a complete spin. 24 hours for it to spin around one time. Every planet has a different amount of time it takes. Some are longer, some are shorter, but it takes a different amount of time for it to spin totally around one time. So a day is how long it takes to spin around once, and a year is how long it takes to travel one time around the sun. All right, let's get started with our planets. So the planet closest to the sun would be Mercury. Mercury is the closest planet to the sun. Because it is so close, it travels around the sun pretty quick. It takes 88 Earth days for it to go fully around the sun, but it spins a lot slower. So it takes 58 Earth days for it to spin around one time. So length of a day is 58 days and length of the year is 88. Mercury has no atmosphere. That means it has no type of air around it at all. So it gets very, very hot in the sun and very, very cold when it's nighttime on the planet, when it's not facing the sun. So it reaches a high temperature of about 800 degrees Fahrenheit. And then at night, when it's that side is facing away from the sun, it can get extremely cold, almost 1,000 degrees colder, negative 280 degrees Fahrenheit. And Mercury has absolutely no moons. Some really cool stuff about Mercury. First of all, its name. Almost all the planets are named after Roman gods or Greek gods. Mercury was named after the Roman messenger god because it travels so fast. So if you've ever seen, I think the Disney movie Hercules or some other cartoons, you'll see Mercury as the Roman god who has those wings on the back of his shoes that make him go very fast. And the reason that we named Mercury Mercury, or that Mercury was named after him, was because Mercury travels so fast. Another interesting piece of information about Mercury is that it has wrinkles on its surface called lobate scrapes. These are caused when the iron core cooled. Remember, on Earth we still have a liquid core, but Mercury is much smaller and it has a solid core. And as it cooled, the planet kind of shrunk a little, which caused these wrinkles, which you can see right here, to form all the way across the planet. And the moon has similar features like this, these little wrinkles that caused from when it was shrinking, when its core was cooling. Mercury does not have any sort of plate tectonics, doesn't have any way for its crust or its surface to renew itself, doesn't have any weather, any rain, nothing like that. So all its craters stay there forever. It is the most cratered planet in our solar system. You can see in this UV picture right here, which shows all these different craters all over the place. Lots and lots of craters. And because Mercury is such a small planet, it has a very low gravity. Its gravity is about 38% what it is here on Earth. So if you took a person, which we can't do, but if you took a person that weighed 100 pounds and put them on Mercury, they would only weigh 38 pounds on Mercury. Pretty cool. So Mercury is the closest planet to the sun, travels the fastest around the sun. And after Mercury comes Venus. Now, Venus is unique in the fact that its length of a day is longer than its length of a year. So it takes 243 days for it to spin around one time. Yet, it only takes 225 days to travel around the sun. So if you were to live on Venus, which again we can't, your year would be shorter than your day. Venus is what we call basically global warming gone crazy. It is when something called the greenhouse effect, which we'll learn about, goes insane. And it's very hot. That causes it to be very, very hot. Venus has an atmosphere, which means it has air of some sort around it. Our air here on Earth is mostly nitrogen and oxygen. And on Venus, it's carbon dioxide. So it keeps heat trapped in there. So the temperature on Venus stays relatively stable, about 100 or 860 degrees Fahrenheit, which is extremely hot, day and night, all the time. And Venus has no moons that we know of. Some cool facts about Venus. Venus is pretty windy. The speeds on Venus of the wind that occurs can reach about 450 miles per hour. Those are faster than any tornado that's ever been measured here on Earth. So its winds are faster than any tornado. One interesting fact is that its rotation, the way it spins on its axes, is in a different direction than other planets. So if you look at this picture of Earth, you can see it's rotating around in this direction. Whereas if we go to Venus, Venus rotates in the opposite direction from all the other planets in the solar system. We think that most likely happened due to a large asteroid hitting Venus and kind of causing it to change its spin, which is interesting. So Venus is a very hot planet. It has a very dense atmosphere, around 97% carbon dioxide, which is a greenhouse gas here on Earth that causes global warming. We have about 1% carbon dioxide in our atmosphere, whereas Venus has 96.5%. That causes heat from the sun to get trapped in the planet and not leave, which is why it's so hot day and night. And also because of the air pressure, there's a lot of stuff pushing down on the surface. That carbon dioxide is a heavy, heavy gas. And on the surface, the air pressure is about 90 times higher than what it would be on Earth. So the next planet, third rock from the sun, is going to be Earth. Length of a year, 365 days. Length of a day, 24 hours. High temperatures in deserts can get up to 134 degrees Fahrenheit. Where lows in Antarctica are about -90. And we have one moon. We'll talk more about Earth the rest of this week. But let's move on to the fourth rock from the sun, which is Mars. And Mars, to me, this is a beautiful planet. Like, look at this planet. It's gorgeous. So, length of a year. It takes about twice as long for Mars to go all the way around the sun one time, 687 days. And its length of the day is closest to that of Earth. We're 24 hours here on Earth, whereas it takes Mars 24.6 hours to spin all the way around. Its high temperatures when it's facing the sun, 86 degrees Fahrenheit. Its low temperatures in the poles, negative 195 degrees. On average, it's about negative 80 degrees. And Mars has two moons, Phoebe and I think Deimos, but I'm not sure about that. Some cool facts. Mars is probably the planet that we are exploring the most as a civilization. We are pretty sure that water at one point used to flow across Mars. We think Mars at one point had an atmosphere kind of similar to ours, and that it had oceans and rivers and rain and all the types of weather that we experience. How do we know that? Well, when we look at the surface of Mars, we see things like canyons or riverbeds, deltas, things that only are formed by running water. Now, when I was a kid, we used to think that Earth was the only planet that had water on it. No other planets had water. But we now know that is completely not true. There are frozen water found in the poles and the North and South Pole and in craters on Mars, which is pretty interesting. Scientists are pretty confident that within the next 5 to 10 years, they will find life on Mars. Not life like green men running around, but life like bacteria or single-celled organisms living on Mars, which would show that life is not unique to Earth, which is pretty cool. Mars is also home to the largest volcano in the solar system. It is 3 times the height of Mount Everest. It is called Olympus Mons, the tallest volcano in all of the solar system. In Mars, if you were to go to Mars, we've never sent anyone, but if we were, and they were to take off a helmet or their spacesuit, they would immediately die because the air pressure is so much lower than that here on Earth. Mars has a very thin atmosphere compared to what we have at Earth. And what would happen is if you took off a helmet, the oxygen that is found in your blood would expand. And that would cause your lungs to rupture, then cause air bubbles to go through, give you a stroke, and would kill you before you would suffocate from lack of oxygen. And then gravity on Mars is 38% that of Earth, much smaller. Astronauts would be able to jump farther, jump higher, take bigger steps, things like that. So Mars is one of the most fascinating planets in the solar system to us because we believe it is most similar to Earth. After Mars, we have an asteroid belt. That asteroid belt contains one dwarf planet called Ceres and lots and lots and lots of asteroids and dust that just kind of rotate. We think the asteroid belt is there because it tried to form protoplanets. It tried to, as pieces of rock would bump into other pieces of rock, they tried to clump together. But because the asteroid belt is in between the Sun and Jupiter, the gravitational pull from Jupiter caused, we think, those collisions to be more violent, and they cause things to shatter rather than stick together, which is why the asteroid belt, we think, never formed a planet. There is a protoplanet, but we don't think it will form a planet because Jupiter is so close to it. And now, after you get past the asteroid belts, we get to our gas giants. So our gas giants are basically made up of lots and lots of clouds, right? They're not solid. You can't stand on them. They're just tons and tons and tons of gases together that form lots and lots of clouds. So some basic information about Jupiter. It takes 12 years, Earth years, for Jupiter to go around the sun one time. But it spins faster than the Earth. It only takes 10 hours for it to spin all the way around. For Jupiter, as as with all the gas giants, as you get closer to the core, or to the very, very center of the planet, it gets hotter and hotter. The average temperature in the outer layers of these clouds is cold, negative 238 degrees Fahrenheit. But as you get closer and closer to the core, it gets hotter and hotter. The core is about 25,000 degrees Celsius, or 43,000 degrees Fahrenheit, which is hotter than that of the sun. Jupiter has a ton of moons, 79. We are finding more each year, so I'm sure that number will go up. When I was a kid, I think it was 10 or 12, and now it's almost 80. It will continue to go up. So I want to just briefly talk about the temperatures, because this makes it seem like it's very hot and very cold. I want to compare the temperatures of all the planets. So this side, this is a picture that this actually gets stacked on top, but the screen isn't large enough. This shows the temperature of the planet at about what we consider surface level here on Earth. So about 1 air pressure unit. The hottest planet would be Venus, right at almost about 900 degrees Fahrenheit, followed by Mercury, and then we have Earth, and then Venus. Now, in these upper layers of the clouds, you get about 179 degrees Fahrenheit, negative. And then Saturn in the clouds, negative, 220. Uranus, Neptune, and Pluto. As you can see, the further you get from the sun, with the exception of Venus, because Venus has all that carbon dioxide, the colder you get. So some cool facts about Jupiter. Jupiter has the shortest day of all the planets in our solar system, 10 hours. And Jupiter has what we are used to seeing when we see Jupiter, this giant red spot right here, the giant red spot. Now that is actually a storm. That storm has been going for over 300 years that we know of. Think of it as a massive hurricane that's happening. It is so wide that 3 Earths could fit inside of it. Sooner or later it will disappear, won't be there forever, but it's just a massive storm that's occurring. Now NASA and astronauts and astrophysicists are not sure what the core of Jupiter looks like. What we think it is we think that way down in here there is a solid iron core, and then very small, and then everything above it is clouds. We're not 100% sure. We know about Saturn. We think Jupiter is probably similar. And then finally, Jupiter does have rings. Most of them are dust. It's hard to see in comparison with the rings of Uranus or of Saturn. So again, with the gas giants, they're not solid on top. They are just lots and lots and lots of clouds, very, very thick clouds. And we believe in the very, very center there might be a solid part, but the rest of it is all clouds. Okay, so after Jupiter, Jupiter has 78 moons. And some of those moons are extremely interesting. Europa is one of them. There's Io, Ganymede, lots of interesting moons. But Europa is one that has what we think water on it in the frozen form, in ice. We think that that Europa is covered in water that is frozen solid that might be 100 miles thick. And we are pretty sure that there's geysers of some sort, which basically means like every now and then like water volcanoes almost erupt from the surface. But it's pretty interesting because, like I said, when I was a kid, we were pretty sure water was unique to Earth. But now we're learning it's really not. So Europa, we think, is covered in frozen water, which is pretty cool. Okay, so the next planet as we travel out is Saturn. Some basics. It takes 29 years, Earth years, for Saturn to go around the sun one time. The length of the day is 11 hours. It spins pretty fast. In the clouds. High temperature of 137 and low temperature of negative 280 degrees. And currently has 82 moons. We are finding new moons all the time with Saturn. But currently has 82 moons. Some facts. First of all, its name. So Saturn was named after a Roman god, and in Roman mythology, Saturn is the father of Jupiter, which is why Jupiter was named after a Roman god. We discovered Saturn. We were like, oh, Saturn, Jupiter's dad. Saturn is one of the windiest planets. It's not the windiest, but it's one of them. The winds in these top bands of clouds have been measured to be about 1,100 or 1,100 miles per hour. So pretty windy. Saturn is a gas giant, which means it's basically all clouds. But as with Jupiter, we believe that there is a solid core surrounded by gases of hydrogen and helium. And Saturn has over 80 moons, and some of those moons are larger than Mercury, larger than planets. They're huge moons. One of the moons that I find interesting is Titan. Titan is the only moon in the solar system that has a very thick atmosphere, and its atmosphere is similar to Earth in the fact that Earth's air, the atmosphere around Earth, is about 75, a little bit more than 75% nitrogen. And Titan has a very nitrogen-heavy atmosphere, similar to Earth. Titan also has oceans, but those oceans are not made of water. Instead, they're made of this substance called methane. So it has liquid methane. And sometimes it snows on Titan, but instead of snowing water, like what we have here on Earth, it will be methane snow, which is pretty cool. So here's a picture of Titan. It's a beautiful colored moon. Okay, so after we leave Saturn, we get to our next planet, which is Uranus. A lot of people will pronounce this Uranus, but it's actually Uranus. Now, Uranus, length of years, it takes 84 Earth years for it to go around the sun one time. Its day is shorter. Its day is 17.5 hours. It is a cold planet with the average temperature being 370 degrees negative below zero. And currently we know of 27 moons. As with Jupiter and Saturn, this is not a solid planet. We do believe there might be a solid core, but basically it is clouds and clouds and clouds and clouds. So it is not something you can stand on. It is gas only. So some facts. So the first fact I think about Uranus is its name. So why in the world would we name a planet Uranus? Well, it's named after the Greek god for the sky. And according to that myth, Uranus was the father of Saturn and then the grandfather of Jupiter. So we found Jupiter, then we found Saturn. We were like, oh, let's name it after Jupiter's dad. Then we found Uranus. Oh, let's name it after Saturn's dad. So that's how it got its name. Now, I find it funny that people call it Uranus and that it is a very smelly planet. It is composed mostly of methane gas, methane clouds. And methane is the same type of gas that cows release when they toot or fart. So that smell is what would be on Uranus, which is funny. I'm going to move to number 4 here. It's very, very cold. Uranus has the coldest temperatures, even though on average Neptune is colder, but it can reach the coldest temperatures of all the planets in our solar system. And finally, the tilt. So Uranus is tilted sideways compared to other planets. Look at the way that this planet spins. It spins like this, whereas other planets spin like this. And we think that happened when Uranus was forming. It was hit by maybe an Earth-sized asteroid that kind of tilted the way that it was spinning. So it spins at a 90-degree axis, which is kind of funny. Okay, the next planet that we have is Neptune. Neptune, it's the furthest out planet, so it takes 165 years for Neptune to go around the sun one time. It does spin relatively fast, 16 hours, reaches temperatures of, its average temperature is negative 350 degrees Fahrenheit, and currently we know of 14 moons. It is named after the Roman god of the sea, Poseidon in Greek mythology, Neptune in Roman mythology. So if you see this dark blue color, it makes sense why we would name it after Poseidon. So Neptune has the strongest winds in the entire solar system. Remember, this is mostly all gas and ice, but it has the strongest winds in the solar system. In the upper atmosphere, it can reach 1,300 or 1,300 miles per hour. Like Jupiter, Neptune currently has a massive storm going on. We call it the Great Dark Spot, and it is about the size of the Earth. So it's a huge storm that's happening that will probably rage for hundreds of years. And then Neptune is also the smallest of all the gas giants. All the other gas giants, Saturn, Jupiter, and Uranus, are larger than Neptune. So past Neptune, we have the Oort cloud, but we also have dwarf planets. So scientists think there may be as many as 10,000 dwarf planets in our solar system. And as we started discovering these planets, we started to realize that Pluto could not be a planet. And there's lots of reasons why we're going to talk about. Here are 4 of the dwarf planets that are past Neptune. We have Pluto, Makemake, Iris, and Hamu. I'm not sure how to pronounce that. And the reason these are dwarf planets is because there are 4 things that must occur in order for a planet to be called a planet. And those rules are, it has to be spherical, round, right? So we see Pluto makes that, Makemake makes that, and Iris is round. This planet, however, this dwarf planet, is egg-shaped. So that counts it not as a planet. It has to orbit around a star. Well, all of these orbit around the sun, so they all orbit around the star. It has to not be big enough to create thermonuclear reactions in its star. What that means is Jupiter and Saturn are made up of very similar elements, or very similar things as the sun. However, they're not large enough for those nuclear reactions to start happening in the core, so it can't ignite like the sun does. And finally, this last rule, this is why these 3 planets are not considered, or dwarf planets are not considered planets. And that is because they did not clear the neighborhood around its orbit. What that means is there's still other stuff in Pluto's orbit. There's still other pieces of material or debris that have not been cleared yet. So all of these kind of orbit in similar paths. Some of them even have, some of our dwarf planets have moons. Pluto has the moon Charon. This planet here has 2 moons. I don't know their names, but it has 2 moons that orbit around. So they may even have moons, but we don't consider them a planet because they have not cleared their neighborhood or their orbit yet. All right, so that was our solar system. I can describe the orbit and key features of 8 planets in the solar system. I do not expect you guys to remember all this information. I would like you to know the basics, right? That we have the rocky planets close to the sun, followed by the gas giants on the outside. Know that things closer to the sun are usually hotter, things further away are usually colder. And that's about all I'm really looking at you to really know. I just find this stuff extremely interesting. So that is the end. I hope you enjoyed your spring break. I don't know why I wrote enjoy spring break. It should say I hope you enjoyed spring break. Remember to check Google Classroom every day. Every day there's going to be new learning opportunities for you. We will post them by 8. And if you haven't already done so today, go watch that quick other 4-minute video I have posted. All right. Thank you guys for getting through this, and I will talk to you all tomorrow. Goodbye.